Okay, this is just a concept that I had to clarify today was covariance and correlation. So I'll kind of walk you through everything that I learned or just kind of reviewed to make sure that I understood it. So first is kind of like covariance. Covariance is kind of just like directional relationship between two variables, x and y. Basically, it means if it's positive, then if x goes up, then y would also likely go up. And if x goes down, then y goes down as well. So it's kind of like in the same direction. Negative correlation means covariance means like if x goes up, y is likely to go down, and so on and so forth, and the other way around. Zero covariance means that their movement is relatively independent. So the covariance of x, y is defined as the expectation of x minus e of x, and then times y of e minus y. And you can kind of use the linearity of expectations to kind of open that so that it's the common form or more expected e of xy minus e of x, e of y. But yeah, over here, we actually don't use covariance that much because it's actually dependent on the unit we're using. So it's kind of like, okay, it really depends on the unit, so it doesn't give us a good measure of like how much the relationship is. So instead we use something called correlation, which I was confused about the notation, whether or not it was um rho or r, because I didn't know because like I thought the two were the same, but apparently they were different. I'll explain later. So here it's basically just a metric that's kind of relative and standardized. So what we do is we divide the covariance by the standard deviations of both variables. So we have here covariance divided by sigma x, sigma y, and that's a correlation coefficient. So it always falls between negative one and one. So we kind of just get an idea that kind of on the extreme one is like very like perfectly correlated into a linear relationship, and then zero means no linear relationship. So that's kind of what the graphs look like, and that's what everyone is familiar with, right? So this was kind of like the clarification of where I kind of got confused was I saw both rho and r, and I was like, what? Basically what this means is that rho is just the common notation for population correlation coefficient. So it's like the theoretical um thing, and just like if we're talking theoretically in the distribution, that's what we use. And the R is a more familiar constant I use from statistics. It's because it's a sample. Every time in statistics, when you take samples, you kind of just calculate R to the best estimate rather than the actual for the population, right? So that was where today I got really confused is what is the difference between rho and R? And now I know the difference. Cool. That's enough today.